Hi there! In this part we'll learn how to create a task on Firestore and get it from the application. So go to Build and Firestore Database, press Create Database. Here we choose Test Mode. In this test mode our data will be open for 30 days. In 30 days you can change the security rules if you need to enable long-term client read and write access. Here you change Cloud Firestore location, but I leave it as a default. So, our Firestore database is ready. Now, as usual, first we add the data manually. The collection is a set of the documentations. In our case, the collection ID is a user email. Now, insert the document ID. It also must be unique. I write random characters. And just for example, I insert 2 fields. You can also change the parameter type. Later, we do this all steps from our application. So, this is just an example of data. Now, let's implement it on the project. First, add Cloud Firestore dependency to pub/spec YAML. Save and I run the project. Don't worry, this error happens because the Cloud Firestore dependency requires the project's min SDK at least 19. So just go to search section and type min SDK, and here set min SDK version 19. Save and close the file. Run it again. This is another error. Here you can read the error and why it happened. Because the number of method references in a .text file cannot exceed 64K. But in our case it's more than 98K. Like many coders, I also don't know how to fix the error. But developers must know how to Google it and find the solution on internet. So I copy the main part of the error and pass it on Google. Stack Overflow is one of the best sites to find solutions. So I go to Solutions, and here's the first solution. It looks easy, let's try it. So we must go to Project, App, Build.Gradle, and here in the default config set the multi-dex enabled true. Save and run the project again. It worked! Now we create a repository folder. And inside it, create a file for Firestore repository. Class name is also Firestore repository. And here we create 2 functions. First one is a create task, and second one is a get task. So these 2 functions work with Firebase and there will be some delay. That's why we create a synchronous future function. This create function receives a task object and we create a task on Firestore using the task object. Try catch is used to execute a block of code that could throw an exception and handle the exception without letting the program terminate. Now using await, we call the Firebase Firestore. .instance, .collection, and here pay attention. We set user email as a collection, so we need the user email here. Go to login screen, and using get storage, first we write the user email on local memory. The key is email, and the value is user email. And here we can get the user email. After collection, the next parameter is doc ID. And I told you before, the doc ID must be unique. So, we can use task ID for it. Here is null safety check, and we know that the task exists, so we can put exclamation mark. And finally, we set data. Here on Firestore, the data is in the form of map, and here we'll also use task.toMap. This toMap function comes from our task model file. And in the catch block, we just throw the exception in the string format. So next one is get function. This get function returns a list of tasks. We create an empty list. Again, we write the code in try catch block. At the end, we return the list. So let's create the task from the Firestore. I create a variable, and again, using the user email, I get all user docs and load to the variable. And using for each loop, I add the tasks. But pay attention, the task is not a task model yet. It's in the form of map. We convert it using the task.fromMap, and at the end, the task model is added to the task list. Here you can see how the fromMap function works. It receives a map and returns a task object. And here, task.data is a map. Now we can return the list here. The Firestore repository file is ready for now. You know this BLoC file from section 3. At the moment, these all functions are empty. And now we create a task using this Flutter BLoC state management. Let's finish the add task first. So, we call Firestore repository.create and send event task. Let's test and create a task. But we had better delete the collection that we created manually on Firestore. So, now it's empty. I'll log into an account and create a task. At the moment, it will not appear here. We have just added the task on Firestore. We have not getting it yet. I refresh the page. And here it is. To collect all tasks, we need another event. I name it get all tasks. This get all tasks event doesn't receive any task object. You can leave the event empty, or you can write the override like mine. It doesn't matter. Save and close the file. Now we create onGetAllTasks block. And here also, I add onGetAllTasks. I adapt it everywhere. We have 4 types of tasks: pending tasks, completed tasks, favorite tasks, and removed tasks. Now here, using Firestore repository get function, we get all tasks from Firestore. After the get function, we write .then. And here in the value, we have all tasks. We do for each. And here we check each task and add it to correct task list. So first, if task is deleted is true, we add the task to removed tasks. and inside else condition. We must check again the task is favorite or not. If yes, we add it to favorites list. This favorite tasks list doesn't depend on pending or completed task list. That's why we need another if condition to determine the task completed or not. If completed, we add it to completed task list. Else, we add it to pending task list. I'll explain the nested if condition one more time. One task can be either deleted or not. If deleted, we add it only to remove task list. And that's all. Or, if it's not deleted, we go inside the else. And here one task can be favorite and completed, unfavorite and completed, favorite and uncompleted, unfavorite and uncompleted. That's why we have here two separate if conditions. And the last thing, we must emit the task state, and we emit all task list here. We have finished the onGetAllTask block. Now, we call the getAllTask event from the tab screen, as soon as the tab screen is active. So, we call it here in the initState function. InitState function already exists. That's why we write override on it. This initState function must call its superclass, and above it, we call getAllTask event. Ready? I save and hot restart the project. And here is our task from Firestore. And by the way, here is the still used hydrated block, but in the task block file, we don't need it anymore. So I delete it. Now, our app is fully working with Firebase and BLoC. One more thing. Here we are only adding a task on Firestore, but after that we are not getting it. So, here in the Add Task screen, we must update the list getting it from Firestore. I call the getAllTask event here. Save and let's test it. It's working perfect. That's all for this part. Ta-ta for now!